Streaming. Starting. All right. Welcome to the UAB Data Science Club Part 2. Last week we had talked about setting up an Anaconda environment, but this week we're going to go ahead and start doing some real machine learning stuff with some real data. So it should be fun. What we're going to do is we're going to use the Kaggle.com platform. Kaggle is a machine learning competition website. And so let's go ahead and go there. So it's just www.kaggle.com. And then on here, they do have these competitions, which have a lot of really helpful and interesting things in them. A lot of interesting discussions go on. But then you can come over here to learn, and there's all these micro courses. And so if you don't have any Python or coding experience, I say, start with the Python. We're kind of assuming that you at least know how to run some code. And so we're going to start in this intro to machine learning piece. And because it's more fun to do than just to look at other people talk about stuff, we're gonna do the first two exercises here today: the basic data exploration and your first machine learning model.
And if we feel that it's necessary for some information from the first two exercises to be shown, we will go back there and show you those particular things in those notebooks. But mostly we'll be doing stuff, and as we come along new concepts, we'll go back there and explain them to you.
So when you go to Kaggle.com, you probably have to create an account if you don't already. It's easy, it's free. If you have any trouble with it, visit us during office hours and we'll be happy to help you figure out what's going on. The nice thing about this platform is similar to our UAB's Open On Demand platform, where you can request resources online. This opens up a Jupyter notebook that actually runs on the Kaggle servers, and so it kind of takes care of a lot of the back end stuff for you. This first exercise in data exploration is important because if you're doing any work, you need to understand your data before you can try to solve your problem. So let's start going down. All right. So in this exercise, we're going to be using house price data. I think we're trying to determine how much a house should sell for based on some things about that house. And so that's the data that we're looking at.
The data set, this data set includes a lot of different columns or different features about the house, like how many bedrooms does it have, what's the lot area, how many bathrooms does it have, and so on and so forth. So based on those data, we'll try to determine what should be the predictive price for a house.
So the other nice thing about Kaggle Learn is it will tell you whether or not your answers are correct. And so that's what this first code block is just loading in the libraries that do the problem checking for this particular exercise. To run the code, you can click on this little blue triangle, or you can click inside the code block and hit Shift Return. And that's what I generally do because I like keyboard shortcuts. And you notice when I execute that, it goes into the next cell, which is markdown or just text. So there's nothing really to run there. All right, so now this is where we start to get into the actual code stuff. And so here we're going to be loading the data. And so this first one is just a path, like you would write a path on Chiha normal file system. So if you wanted to download this data and then make this work, all you'd have to do is change this path to where the train.csv file is. It looks like the first thing we got to do is fill in this line here to read in to the variable home data. So we actually have to read in this file. This one just specifies what the path is, and then we actually have to read it.
And so for reading in this file, as you would have noticed that we are importing a library called pandas. So pandas is a basic library that allows you to manipulate your data and work on your data and explore your data a bit. So one of the features of pandas is data frame. Data frame is basically where you'll see that your data is in a tabular form, and you can use data frame to explore more with that in pandas.
Yep.
Now, pandas also provides us with one utility where you can read CSV files, and that's what we are going to use. Since we have defined import pandas as PD, so we can just use PD dot and all the different methods described in pandas.
Yeah.
So it would be PD dot read underscore CSV.
Okay. I always forget these, so I generally have to look them up. There we go. All right, so now this should read in the CSV file, and you see this check. That's a function of this learn tools up here. And so if everything runs well, let's see what that looks like. Yeah, so it says correct. If you're having troubles with this, they also have these hints and solutions, which are nicely helpful.
And all of them are commented out. So if you wanted some hint, just uncomment that step_1.hint part. It just means just remove that hash symbol in front of it and then run that.
Yeah. All right. So now what we're gonna do is they're asking us, so now we got to print summary statistics. If we just printed out the whole kit and caboodle, you'll notice that there's just a lot of data. It's not terribly helpful, and so we want to get some description of what's going on with the summary statistics. Is that
yeah, so it's again one of the,
I think it's that function.
yeah, I don't think we need print function. So dot describe all.
Oh, I
Prints
don't
it by
even need.
default.
I don't even need the print function. Okay.
Yeah, but you need two parentheses at the end. Get those. What are these brackets called?
Yeah, parentheses. Yeah. All right, there we go. Oh yeah. So that's really nice. So as Ravi was about to mention, this dot describe function is a pandas function, and it gives the summary statistics for each column in the CSV file. And so you can see that there's a lot, whether or not there's a full bath, a half bath, all sorts of stuff.
And it does give you a lot of statistical information, like what's the total count of all the different rows in a particular column, then the mean, what's the 25 percentile, and standard deviation, what's the minimum value in that entire field and the maximum value in that entire field. You get all those data over there.
All right, now I'm trying to, oh, here we go. All right, so now they're asking us to do the average lot size. And so I think we can just address it this way. I think if we use the sum function here, will that work?
Yeah, divided.
Divided by the length of data dot plot area. All right. So the average is, of course, the sum of all of the observations divided by the number of observations, and then let's see, the newest home age is probably the maximum of that column, don't you think?
Yeah.
Data dot year built. All right, let's give that a shot. Okay, so I didn't calculate my lot size correctly.
So I think we can use the information that we have up there to actually just write the value over here. So average lot size would be just, I think mean.
Yeah, just right here.
Yeah. So and just
So
to the nearest integer. So
you're saying I
15.
I overthought it.
So you need 5/17. You have to round it to the nearest integer.
Oh, that's right. That's right.
And the second one would be.
And then the second one would be.
So you see, it ran the first one
max.
correctly. Max. So yeah. So the newest home age that it was built in was 2010.
Oh, okay. Because that was the max year built.
Oh, as of today, how old is the newest home?
Current year minus the date which it was built.
Yeah.
So that would be 9. There we go. All right, and again, if we had gotten stuck, we could have looked at these.
Yeah, so it says that once you have run that describe command, you see the lot size in the column called lot area and year built, and you could use this information that you got from the .describe command and just fill in those values.
Yeah. All right, so now we've gone through exploring your data, and that gives us a little bit of a handle on different things that we can do with the data and the distribution that we have. So now we can go back to that learn page, and we can move on to our first machine learning model. And this will take a little minute to get up and running, I think. I believe the model that we're going to use here is something called the decision tree, and it ends up looking like this. And so it just kind of divides the houses into multiple categories and tries to predict whether or not the price is going to be something or something else based on the variables that we input to it. Let's look back. All right, so again, we've loaded data and we reviewed it, and so we can run this cell here and it'll bring us back up to speed from where we were at. So we had the file path for the CSV file, we read it in using pandas, and then these learn tools are just for the code checking portion. All right. So there's a lot of columns in this home data, but we're primarily interested in predicting the sale price. And so we're going to submit the sale price as our Y variable. Oh, I've run this before. That's why that's why some of this stuff is already filled in.
Oh, okay.
So let's see. Let me see if I can get it to revert back to the older one. Versions, settings.
Can we do it by a file? Does it have file versions?
File,
No, it doesn't have.
edit. Selection, help. All right, well, we'll just talk through it. You'll notice that mine has things already filled in because I was kind of pre-gaming this notebook a little bit and just trying to understand what was going on. So here we were supposed to fill in, this was set to blanks, and we were supposed to specify what we wanted the predicted variable to be. And so that's where we'll put in this home data, and this should be sale price. Here, I think you can also specify it as dot sale price. Yeah, that also works. All right. And so now we're going to create the X variables, which is just all the stuff that we want to use to predict the Y variable.
Yeah, because we saw a lot of columns in this particular table, and all of the data is not really useful in predicting the price of a house. Some of the things that you'll think that are useful in predicting the price, we'll take those particular columns and create our own table with them. So the things like lot area, year built, first floor, second floor, full number of full baths, and all those things actually matter to the price of the house.
That's our assumption anyway.
Yes, that's our assumption.
Yeah.
And so we are going to take those fields and create a data frame for us, which we are going to utilize to predict price for a house.
Yeah. Now when y'all do this, you'll notice that this is blank, but this is how I filled it in, was to specify an array of strings that has all of these here in this column that they specified. And then once you have that list, you can just pop that array of strings into your data frame, and it will return kind of a subsetted data frame into this variable X. And so if we look at the hint and the solution, it shows the same thing that I had up here. All right, so review data, like in that describing our exploring our data piece earlier that we looked at, we can use that describe function, and there's another one. Oh, that doesn't show it in here, but there's a describe function that shows the summary statistics, and then there's another really nice function that just prints the top few lines, which is head. Oh, what did I do? Oh, I didn't actually run my code over here. There we go. If you scroll down and you run a later cell without having run a previous cell, you'll end up with something like this, where variable X isn't defined, even though it is earlier in the notebook. I just didn't run that cell. All right. So here we go. Not sure. Oh, this is what you were saying. I don't actually need these print functions around this. Oh, does
So yeah, I think it only prints the last line that it ran. So
I gotcha. So if I wanted to see the describe, and I need that, there we go. I might actually have to say print to actually get it to pop out.
yes.
Okay. All right. So now we're going to specify the model that we're going to use.
Oh, one thing in the previous
Yeah.
column, it's actually a very good idea to at least see the head, to use that dot head function, because it's a good idea to visually see your data, uh, at least some of your data. I mean, we are just using 5 over here, but it's a good idea to at least see the first 50 rows or so of your data so you have a general idea of what your data looks like. And in 50 or 60 rows, you might be able to find some issues with your data where you might need to manipulate your data a little more so that it's actually useful for running uh, where it's useful for running your machine learning model.
Yeah.
So, for example, if you saw that in these 50 columns, there were a lot of columns where your build was 0, that actually doesn't make sense, but maybe they didn't have data for that year, somebody forgot to put in the value for that year and all those things, then you might want to either remove those data from the entire data frame, or you might want to put some predictive or some guessed data over there, some guessed year.
Yeah, the other thing that you'll notice is, like in this particular set, in the second floor square foot column, there's a lot of zeros. And so it kind of remains to be seen how useful that column is, since it looks like most houses don't have a second floor. So I'm not sure how helpful that column will be for predicting, but you know, we can always try different things. And as Ravi mentioned, you can change this number in the head, and it will change the number of columns or number of rows that it prints out. So I specified 10 and it went 10, and then when I had 50 earlier, it ran 50. All right.
Remember, in machine learning, manipulating your data is a big chunk of what you do so that you have your data right for your machine learning model. So having this head function and the describe function helps you in doing those things.
Yeah. All right. And then when you come into this cell, it's going to look something more like this, where you don't have the Python library called. And so as it mentions up here, we're bringing in a library from scikit learn, which is this one dot, and this is where I get, I think it's under dot tree because we're doing a tree model. We're doing a decision tree. And there it is, Decision Tree Regressor. And we're using a regressor rather than a classifier because we have a continuous variable. The price isn't a class. It's not like cat versus dog. It's a range of values. And so I wrote this wrong. We need to do import. There we go. All right. So yeah, from scikit-learn.tree, import decision tree regressor. All right, and then here, this is where we create our model. And so we're gonna do that, and you'll see if I just tell it to do it, it's gonna say, hey, I forgot something. And that's because they say to specify a random state. And the random state, it doesn't matter what number you put in here. You can put 13, whatever you want. The point of putting in a random state is to help encourage your model to not overfit or find a local optimum too soon, but to actually fit the data that you have. All right. And so now that we've fit our model, we can actually make some predictions. And so we're gonna take a look at that. All right, so here, again, Python makes this pretty easy, and scikit-learn really helps out. You saw up here we said Iowa model.fit, so that fit this decision tree model to our input data to fit to our output data, the X to our Y. And then now we're predicting from our X what the values of these houses should be using the model, and it's just model.predict. It's really, really nice and straightforward. And so you can see we have things that look like house values, $208,000, 181, 223K, things like that. And so then after that, we got to start thinking about our results. Do they make sense? Is anything shocking in this data? And so one thing that's interesting to see here is they've asked us to print out the first few values of our predicted results versus the first few values of our actual results. And so these first four here, or first five, are the ones that we predicted, and then the next five are the actual values. Do you notice anything fishy in those?
Yeah, they are exactly similar.
Yeah, so anytime you're doing really any kind of modeling, if you get exactly the right answer, there's a very small chance that you are exactly right, and a much larger chance that you have a model that just was able to overfit the data and kind of memorize what the values should be. So I think that's where this is headed a little bit. So we've built the model, and now we want to explore a little bit more, like, is this a good model? Is this a bad model? And that's something we'll look at in a future session. But today we really wanted to get through at least going and actually making a machine learning model. You can take this particular Jupyter notebook and you can run this on Chiha or really anywhere else you run Jupyter notebooks, and take out the house price CSV file and put in just about any other CSV file. You might have to clean it up a little bit, but you can really use this exact same code to do machine learning on a pretty wide variety of stuff.
Yes, I agree. If you have any sort of tabular data where you think you can use this, just replace the house price.csv file with your own tabular file, and you should be able to run kind of almost similar with some very slight changes and get a machine learning model up and running.
Yeah, and if you have any questions about this, feel free to email Ravi or myself, or send us a message on this YouTube channel, or just come into the Research Computing open office hours on Wednesdays from 1 to 3 or Thursdays from 10 to noon. But until next time, we will see you guys later.
Thank you.